CEO of our company, the Royal Martian. What do we need to do? We need to be able to move. Just like a cruise ship down here on Earth, our Martian cruise line should be able to move our passengers from point A to point B. What does this mean? That means we need to develop motors. How will we do this? We're gonna develop a way to measure the volts and the RPM that the motors output, because those two will be directly proportional to each other. The more volts we put into the circuit, the faster the motors will be able to spin. That's kind of the whole thing. We're trying to transport our passengers from place A to point B to point C all around Mars so they can experience the true beauty of the Martian planet. Here's one of our best employees, Cole Reinhardt. Can you tell us how we're gonna do this? What's kind of the plan? What's the idea behind the motors?
So we're gonna use the potentiometer to change the amount of volts that we input, so which will change the RPMs on the motors, and then each like different range, so slow, moderate, fast, and then stopped, will each have a different LED which corresponds to them, so that we know what speed we're traveling at and what would be optimal for the conditions on the surface at that time.
Let's check out how the rest of the team is doing.
So, Trent, are you drawing a schematic like we did in the film or something, like a sketch or something?
No, it's like, you know, I've been going over in class.
Yeah. So you need to include all the LEDs and stuff like that, label where the volts are.
Is it just gonna look like you're just gonna draw everything?
Yeah, because that's what it is for the whole circuit board.
I really need to double check if there's an actual just sketch, but I don't think so. And
So,
then me and you gotta figure out what to do in the code here.
When do you want to talk about the difficulties and stuff?
Most likely tomorrow's Thursday, so probably towards the end of class today, we'll talk about this stuff and this stuff. And again, we have to do this. This is the most important stuff that it's due.
Well,
After we get the video done and everything else.
I'm still concerned about the vertical part, because Cole was kind of right about that.
You know, it'll make it seem like it was kind of out of the way, not kind of like actual, like everybody knows, oh, we're recording this, is kind of like out of the
I think it'll still look fine.
Yeah, it looks fine, yeah. Because it's kind of just like quick in a sense. It's not like the main part of it. Yeah, and we have all the names and stuff. Yes. Alright, so we'll be fine. We have everything else done. We just need to finish up the actual video and stuff like that. So we'll be fine.
And then we need to. Have you done the code or something?
Yeah, I made the code.
We need to get a picture of that.
Yeah, just upload a picture of the code. Take a code. Is there a way to get it into Python and not block code?
Well, it can still be block code. The block code
can still be block code.
It just there's also Python.
I think bot wants Python.
We can ask him.
Yeah. I can't do it.
Debating between either using
Wow, let me plug it in. Okay, let's just. Oh.
Trent, what are we doing here?
Oh, okay.
We're trying to figure it out too.
Okay. Wait. I figured it out. So, after using my professional.
I know it's RGB. I know this green and blue.
It's so. See how the prongs are RGB? That means it takes the amount of current put into it and displays it. So this can be tied into.
We were debating whether to do that or just the 4 LED steppers. Which one should we do?
Oh, see, this one would be a little bit trickier to program, but you can say like, so based on the amount of current or based on the amount of volts going into the system, the color would change by itself.
Yeah.
So then we would just say like,
It would be
okay,
just signified
we
based
made a
off
little
of that.
adjustment that.
Also, all you would have to do is put the LED through the system
Yeah.
instead of having to program it separately.
Yeah.
So I think it would probably be.
Yeah, you don't have to program anything. Yeah, but you just have to say like
We would have to, like,
when the
specify
color is,
colors.
yeah, we would have to say when the color is this, and this. That would be the different thing. So I would just do a little test, see how it works.
Alrighty.
Alright.
Templates, we need to know how they work. Yes, we do. We have to. Yes.
How about we just
We have a basic idea.
Guys. We don't. We looked at one template last time and we were just like, what is happening?
How about we use Copilot? I think Copilot may actually know what Copilot will do. Okay, wait.
Guy, what are we
I think
doing?
it's the amount of light.
I'm trying to figure out how this RGB LED is working.
like how to make it work, you know?
It's the amount of electricity going through it, basically. So
LED explodes at 9 volts.
What'd you do?
I did some calibrations
where are you doing this?
in the other one.
Yo, why is all the wires the same color?
What's going on, man?
Some
We
light
have a test-
engineering work.
We have a test one. You know, we made a test one, so we can actually like test with the LED stuff.
Gavin, what'd you do?
So right now it's going at a slow RPM, but when I crank it up, it turns more blue.
Yay! Sure, what are you working on?
Right now, I'm working on how to connect all of the. It's loud. I'm working on how to connect all the pieces so that if somebody wants to assemble our part, they can do so safely.
Good job.
What are we working on? Whoa, what is this?
It's called a brain break. I'm just.
What brain break? Your brain break is coding.
I was.
What is that supposed to mean?
Yeah.
Come on, hey, I pay you one of the highest salaries in this company.
I am-
And you're out here on chess.com while everyone else is in there working their butt off.
My most sincere
I don't
apologies.
care. Take me your glasses. You don't need them. I said get to work. That's all you're supposed to do. Get your... No, hey. You don't need those. Go to work. Go. Go. Work.
How you doing, Gavin?
I'm just trying to work on my code after the incident.
So how's that code coming along? You working out, buddy?
It's going pretty well so far. So how it works is this battery, it powers up this bottom row, which all these use. So it starts with powering up the potentiometer, which is also connected to the motor via this resistor and some wires. The potentiometer also is wired to the negative output thing. Same with the motor. The multimeter is also connected to the potentiometer and has a discharge down here.
Oh, what's this? What's this blue thing down here? Can you explain that?
This is the Arduino. This is where the fun stuff begins. This is where I'm able to code it and have it work properly. I have these colored LEDs connected to some inputs in here. And then as you see in the code, these same inputs with the numbers, they are right here. I just have to find them. Right here. My glasses make it a little difficult, you know.
But see how things work and how lovely everything is when both of our employees are doing such a great job working and not playing chess.com.
It was only that one
That's your
time.
first warning. You get 2 strikes and you're out.
You see here, this exclamation mark here makes the LEDs look like they're about to explode. It's not safe at all. You need to fix it.
Maybe I'll have to talk to the programmer about that, see if we can get that fixed.
When we try to test these? Yeah.
Oh,
They,
I see what you're talking about. They look like they're on the verge of exploding. In order to fix this problem, we can decrease the power value from 100,000 to a mere 75.
that's a good idea.
So then, I changed it on the red light bulb. The other light bulbs are still problematic right now. But as you see, since I changed the red light bulb to 75, it appears to be normal.
Guys, we've come a long way since the beginning of this project. And I feel we've all learned valuable lessons. I think we should all share what we learned. Let's start with Colton. What did you learn from this project?
Well, I learned how we have become a team together. And as I recorded all of our clips and stuff through the process, I've seen we are all hard workers and get stuff done on time.
Yes, everyone does have their individual strengths, weaknesses, but as a team, that's what makes us strong. We know where we lack in better terms and where we are great. That way everyone can fill it. Now, Trump, what did you learn?
So I've learned, based off the schematic drawings, on how to make it more efficient and effective to convey the information to others. Since, say, Drew, can you see, look at it, what is happening? All right, well, I tried my best. But what about you, Paul?
Oh wow, that's very detailed.
Thank you.
Yes, communication is another great skill that we all learn. Now, we're gonna go, Drew, what did you learn?
I've learned that each part can have very dangerous sections in it, but with proper care and efficiency, they can be made safe and efficient.
That's great. Yes, safety, especially when you in a real life scenario, safety of passengers, whether it's airplanes, cars, members on a cruise ship, it's very important. And to learn like kind of that attention to detail, that every small part can have ultimately a big effect on the end project. Cool. What did you learn in this project?
I learned a lot about how to troubleshoot using the Arduino to solve the problems, which it's really important for my job to be able to fix the problems and work with others in order to fix those issues.
That's awesome. And I would love to share mine. What I learned is how to motivate and be a great leader. I know everyone has their busy schedules, everyone's a little busy with this and this and that. Well, it's called life, but I've learned how to kind of work our way around it and kind of persevere through this difficult project.